Okay, let's try to solve one of the quizzes of physics students. Okay. Assume there is a box, a 100 kilogram box, and there are 1, 2, 3, 4, 5 forces acting on it. One is pushing to that direction, a 50 Newton pushing to left direction, a 2200 Newton pushing to the right direction. Okay, 100 Newton pushing downward at an angle of 30 degrees with the vertical. Another force 150 Newton lifting the box, and a 100 Newton at the line of action. The slope of the line of action is 3.5. Okay, so we will find the net force acting on the box. What is the acceleration of the box as it moves? Okay, so since there is a net force, of course there will be a acceleration. Okay, what is the final velocity after 10 seconds as it moves, and what is the distance traveled after 10 seconds? Okay, first thing to do is we're going to resolve the components of the forces such that all these components will be parallel to the surface and perpendicular to the surface. So with 50 Newton and 2200, we don't have problem because they are already in parallel with the surface. Together with 150 Newton, they are already perpendicular with the surface. Okay, so what we're going to resolve is the 100 Newton and the other 100 Newton there. Okay, so this is the x component of the 100 Newton to this direction. Okay, we have also the y component downward. Okay, y component downward, and the x component of this 100 Newton will be, if this is 30 degrees, this is 60 degrees, this will be 100 cosine of 60, and this will be 100 sine of 60. Okay, with this regards, we have 3, 5. The hypotenuse is square root of 3 square plus 5 square. We have 5.83. This is 5.83. Okay, so the x component will be to that direction, going outward, together with the y component. Okay, the x component will be 100 times 3 over 5.83. The y component will be 100 times 5 divided by 5.83. Okay, so let's try to solve. The x component is 100 cosine of 60. 100 cosine of 60. 50. The y component is 100 sine 86.6. 86.6. And the x component here is 100 times 3 over 5.83. 100 times 3 divided by 5.83. 51.46. 51.46. Nih, madi. Dito x component 51.46, and the y component is 85.76. This is 85.76. 85.76. Okay. Okay, so we have resolved so we can neglect now 100 because we already replaced by x and y component. Okay, we can also neglect this one because we are already replaced by 85.76 and 51.46. Now let us compute the normal force. Okay, normal force exerted by the surface on the block. Okay, so normally this is the normal force is acting perpendicular with the surface, and this is the net sum of vertical forces. Okay, so our vertical forces will be 85.76, we have 150, we have 86.6, and we have the weight of the box. We have the weight of the box, 100 kilogram. Let us transform this to Newton. 100 times 9.81. This is 981. Okay, so the normal force will be 981 minus 86.6 plus 85.76. Ay mali. 981 plus 86.6 minus 150 minus 85.76. Okay, so 981 plus, kasi downward ito eh, plus 86.6 minus 150 minus 150 minus 85.76 minus 85.76 percent. May isa, dua, talo, pat. Okay, 831.84. Okay, this will be the normal force. This force is acting perpendicular, always acting perpendicular with the surface. Okay, now we have the frictional force between the block and the surface, but the direction, let us check the movement of the box. If the box will go to the right, then the frictional force will be to this direction. If the box will move to the left, it will oppose the movement of the box. Now, checking the horizontal forces, we have 50, 50, 51.46, and we have 2200. Okay, the box will definitely move to the right. Okay, because this is very big, 2200 newtons. Okay, so when the box moves to the right, then the frictional force will oppose the movement of the box, and that frictional force gives us mu n, which we will use the mu, the coefficient of friction. This is 0.3, and static and kinetic is 0.28. So we will use since the object will be moving, we will use 0.28 times the normal force, 831.84. Okay. So 0.28 times 831.84. We have 232.92. Now we are now ready to analyze the system, since all forces now is horizontal and perpendicular with the surface. Now find the net force acting on the box. For number 1, assuming to this direction to be positive and to that direction is negative. So we have to that direction is 2200, okay, minus 50, then we have minus also, minus 51.46. We have also the frictional force of minus 232.92. Okay, so check all horizontal forces if you already considered. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so this is the net force acting on the box. 22 minus 50 minus 50 minus 51.46 minus 232.92. We have 1815.62 newtons. Okay, so this is the net force acting on the box. To which direction? To the right. Okay, to the right. So the box now is moving. When the system is released, the box will move to the right. Okay, next, what is the acceleration of the box as it moves? Since there is a net force acting on the object as per the second law of the Newton's second law of motion, that when the object is acted by a net force, the object will accelerate at to the direction of that net force. Okay, we have in formula, we have F equals mass times the acceleration. The net force acting on the box is 1815.62, and that is equal to a mass of 100 kilogram times the acceleration. So this is the acceleration. This is the acceleration of the box. Okay, divided by 100, we have 18.16. 18.16. Let's use 1562. 1562. This is in terms of meter per second square. Meter per second square. Next, number 3. What is the final velocity of the box after 10 seconds? We have the 4 formulas as I introduced before. We have the final velocity is equal to initial velocity plus at. Distance is equal to VIT plus 1/2 AT squared. We have final velocity squared plus initial velocity equals initial velocity squared plus 2AD. Just recording the formula so that we will know what is the appropriate formula to be used. We have distance is equal to the average velocity times the time. Okay, so since we are required to get the final velocity, so maybe we can use this formula. Okay, so that final velocity is equal to initial plus at. This is positive because the object is accelerating. Okay, the initial velocity of the system is 0, so we have the acceleration of 18.1562 times the time of 10 seconds. So we have 1.56 meter per seconds. Okay, this is the final velocity of the object at 10 seconds after release. Okay, and the last one, we have what is the distance traveled after 10 seconds. Maybe we can use the second formula, D is equal to VIT plus 1/2 AT square. The initial velocity is 0. We have 1/2. The acceleration is 18.1562 times the time of 10 square. So we have 0.5 times 18.1562 times 10 square. So this is 907.81 meters. So this is the distance traveled by the box when the system is released after 10 seconds. Okay, so let us summarize. When the box is 100 kilogram acted by 5 forces, the box will move to the right with a net force of 1815 newtons and with an acceleration of 18.1562. When the box is continuously moving, the final velocity at 10 seconds is 181.56 meter per second, and the distance traveled is 907.81. Okay,